In this video, we'll be starting with group theory. As the name suggests, group theory revolves around groups. So let's first understand what are groups. So for this, we'll start with an example. Just consider a 6-hour clock. So 0, 1, 2, 3, 4, 5 and 6 is 0 itself. So we are starting giving the numbers from 0. So the set corresponding to this 6-hour clock can be written as 0, 1, 2, 3, 4 and 5. Now we'll just try to make some observations in this example. Firstly, let us add any two elements of this set. 2 plus 3 gives us 5, right? 2 plus 3 means 3 hours are added to 2. Okay, so we reach 5. Now, again you consider 3 hours plus 3. That gives us, actually 3 plus 3 gives us 6. But now we are considering this clock. So 3 hours plus 3 will take us to 0. So we get 0. Now 3 hours plus 5, that is we are adding 3 hours to 5. So 1, 2, 3. We come to 2. Okay, so in this way we can add any two numbers in this set and we get a number from the same set. Okay, now we will also observe that adding any number to 0 always gives us the same number. 3 plus 0 will give us 0 or 3. 5 plus 0 will give us 5, right? So adding any number to 0 is giving us the same number. Adding any two numbers of this set take us to a number which belongs to the same set. And they're also corresponding to every number. Suppose we take 2. So there exists a number in this set such that adding the two numbers gives us the element 0. Okay. So adding 4 to 2 will give us 0. Adding 3 to 3 will give us 0. Adding 5 to 1 will give us 0. And all the elements of this set are also following associative property. Okay, so associative property is also being followed by the elements of this set. So this was our first example. Now we'll consider another example, that is symmetries of square. So the elements of this set are R0. R0 means a rotation of 0 degrees. R90, R180, R270, H, V, B and D dash. So we have 8 elements in this set. So R0 is a rotation of 0 degrees, that is we are keeping the square in the same orientation. So we have this square A, B, C, D. So R0 means we are keeping the orientation same. Now R90 means we are rotating it by 90 degrees. And we will consider that it is being rotated in anti-clockwise direction, this direction. R180 means we are rotating it by 180 degrees. R270 means rotating it by 270 degrees. And H means we are reflecting, we are flipping the square about the horizontal axis. V means we are flipping the square about the vertical axis. D means about the diagonal. And D dash means about the other diagonal, right? Now all these elements together gives us all the orientations possible for a square ABCD. Now just see, if we combine any two elements of this set, suppose we say R90 and R270, we are combining these two elements. That is, first we'll rotate the square by 270 degrees and then we'll rotate the resulting square by 90 degrees in the same direction. Let us see what do we get. So rotating the square by 270 degrees will give us the orientation ABCD will become BCDA. Okay, so we'll get this orientation after we rotate this square by 270 degrees in anti-clockwise direction. Now R90, R270, 270 degree rotation is done. Now we'll apply 90 degree rotation on this resulting square. So the resulting square is BCDA. Now 90 degree rotation. This AB side will come at the bottom after rotating it by 90 degrees. So we get A, B, C, D. Now look, this orientation is similar to the orientation with which we started. So can we say that R90 and R270 on combination give us the rotation of 0 degrees? Because we are reaching the same orientation with which we started. Right? Similarly, if you consider, suppose this is the square A, B, C, D, and you are flipping it about the horizontal axis, that is, you are applying H, you are applying the operation H. So what you get? You get D, C, A, B. Now you are flipping it about the vertical axis. What you get? You get B, C, A, D. Now this orientation is also similar to a rotation of 180 degrees. Like if you will rotate this figure ABCD by 180 degrees, you will get the same orientation. So combining any two operations of this set, we are getting an element of this set only. Also, by combining any element of this set with R0, that is a rotation of 0 degrees, we get the same element. If you combine R90 with R0, then you will get R90 only. If you combine H with R0, you get H only. So combining any element with R0 is giving us the same element. Moreover, just this example we consider R90 with R270. What did we get? We get R0, right? So they corresponding to every element, हर एक एलिमेंट के corresponding हमारे पास एक एलिमेंट ऐसा मिलता है जिसको हम इसके साथ कंबाइन करें तो हमें R0 मिले. और इस सेट के भी सारे एलिमेंट्स एसोसिएटिव प्रॉपर्टी हमारी फॉलो करते हैं. तो इन दो एग्जांपल्स में हमने देखा कि first, combining any two elements of the set with respect to a given operation, we always get an element from the same set. That is, in the above examples, if we were combining any two elements of the set, then we were getting an element from the same set, right? And I have written here with respect to a given operation. So in the first example, the operation was addition, clock addition, right? The way we add numbers in a clock, that way we added the number. So the operation was addition. And in the second example, symmetries of square, the operation was function composition, like we did R90, R270. So we were applying function composition. First we were applying this operation and then we applied R90, right? So this property is named as closure property. Combining any two elements from the set, we are getting an element from the same set. Now the second property which the examples showed was combination of any element with a element gives us the same element. Like in first example we had 0, whose combination with any element of the set gives us the same element. Like 1 plus 0 was 1, 2 plus 0 was 2, like that. And in second example it was R0. So these elements, such elements are called identity element. So we found identity element in both the sets. The third property was that corresponding to every element X, there exists an element X inverse such that their combination gives us the identity element. So in the first example, we saw 2 plus 4 is 0. 0 is the identity element, and corresponding to 2, we are having an element 4 in the set which gives us the identity element. And conversely also 4 plus 2 is 0. So corresponding to 4, we are getting an element 2 such that it gives us identity element. 1 plus 5 is 0. Similarly 5 plus 1 is 0. So these elements are called inverses of each other. So here we say 4 is the inverse of 2. Okay, so this property is existence of inverse of each element. R90, R270 gave us R0, which was the identity in the second example. H with H gave us R0, which was the identity. So H inverse is H itself. Inverse of R90 is R270. Inverse of R270 is R90. And the fourth property was that all the elements of the set followed associative property. Okay, so a set which follows all these four properties is called a group. Okay, so I hope that I was able to give an intuition of what a group is. Now in the next video we'll be discussing the formal definition of a group, and we'll take this topic further. Thank you so much.